Okay, and capacity. So let's take the words rely, RE, able, and capacity. So what does that mean? We want such a measured variable which is having a reliability, which means that if I carry out the same research after some years on some other participants, I am able to reproduce this result. Okay, little bit confusing. No need to worry. Let us make it simple. You are having a weighing machine. You are having a weighing machine. You measured the weight. You measured your weight right now. And you got, say, for example, 50 kg. After 5 minutes, again you measured it. Will you get the same result, 50 kg? Right. It means that your weighing machine is reliable. Okay, it's reliable because there is a consistency. There is a consistency in your scale. So now the word which has emerged is there is a consistency in the scale. So your scale is consistently giving the correct results. I hope things are clear. Okay, is it clear now?
Yes, sir.
Yes.
Okay. Now let us talk about validity. Now, what is the difference between reliability and validity? Okay. Can I me- can I measure the temperature of a person with the weighing machine? Can I measure it? Can I measure it?
No.
No,
No,
sir.
sir.
It means that can I measure temperature of the person? It means that weighing scale is not a valid instrument to capture temperature. Okay. I am having a questionnaire of loyalty. Can I use it for satisfaction? Can I use it for satisfaction?
No, sir.
It means that this is not a valid scale. And therefore, in scale, whatever scales we are having, we want a scale which is reliable, able, enable, and valid, right? We want these properties. To establish this property, we go for reliability testing, convergent validity, and discriminant validity. Shall I proceed further? Okay, shall I proceed further?
Yes, sir.
Yes,
Yes.
sir.
Right. So there is one question in front of you. I'm sharing a screen again, and you will have to tell me Now, which scale is reliable? Which scale is reliable?
First one, sir.
Okay. Anybody else? Which scale is reliable?
First one, sir.
Okay. Any other answer? Any other answer? Quite surprisingly, both are reliable. Why? Because both are consistently giving the same answer, right? So each ruler will give the same answer consistently. What I told you, there is a consistency. Here, 2 is not there, but it will give you consistently wrong result and consistently right result. Both are reliable. Don't get don't get surprised, right? Both are reliable. But the problem is we don't only solely rely on reliability. There is something which is known as validity. This means that this scale is not valid. This is a good ruler, this is a bad ruler. That was reliable. The scale is reliable, but it is not a valid scale. Is it clear? Shall I proceed further now?
Yes,
Shall I
sir.
proceed? Okay, I hope there is no question now and there is no confusion in reliability and validity because we are going to discuss this thing in length, right? Shall I proceed? Okay. Now, let us say that we are having a construct which is loyalty. Now, this construct, before I proceed further, let me remove this part and use some another example, right? Uh, I'm going to make a football team, right? And for this purpose, I want the players, right? I want the players. Now, my question to all of you is, whom will I select? Which players I will select, right? Whom will I select? Anybody can answer this part? Whom will I select? Whom will I select? I'm making a football team. Whom will I select?
Those who play football efficiently.
Uh, Not efficiently, consistently their performance is good, right?
Yeah,
So
that's that.
one characteristics which I'm looking for is consistency. Do you all agree? Consistency. Right. Okay. Can I take any player who is playing cricket in the football team? Can I take that? Can I take a player who is playing
No,
a
sir.
cricket? So
No, sir.
no, I cannot take. So the cricket player is not a valid player in the football team, and therefore I require a player who is playing the football only, right? So I require a player, a valid. So this talks about reliable. Is my player reliable? And is my player valid? These two conditions we are searching for in the player. Now, what will be my criterion for the selection of the player? I am having a pool of players. Whom will I select? I am having, say, for example, 15, 20 players. Whom will I select from this pool? Whom will I select?
Those who have scored maximum in the past matches.
Very nice. So whose performance is better, who can represent our team in a better way? We are looking for this. So simple. Huh? Let us try to borrow the same concept in our social science. I am trying to capture loyalty, and I am also searching the statements who can represent the loyalty in a perfect way, right? Whose performance is good. Is it clear? Now, this football team does not have its own identity. It is not playing. Football team is not playing. Just listen carefully. Football team is not playing. On behalf of football team, the players are playing. So the performance of the player is considered as a performance of the football team. Similarly, loyalty will never be there in your questionnaire. In your questionnaire, measured variable, the statements which you will be asking on the Likert scale will be there, and its performance is a reflection of the loyalty. Is it clear?
Yes, sir. Sir, presentation is not visible, sir. Hello. Well, sir. Hello. Hello.
Yeah, hello. Okay, hello.
Yes. Sir, could you just present again because the screen is not visible, sir?
From where? From where it is not, it was not visible?
Sir, that football one, we could see that. Could you just? Yes, yes,
Yeah.
yes.
Okay. So it means that we want such statements which are true representative of the loyalty. Is it clear? Is it clear?
Yes, sir. Yes.
Now, how much performance we will consider that the loyalty is there? So we want to say that any statement S1, it should at least contribute 50 percentage to the loyalty. It means that at least S1 should be representing loyalty 50%. Similarly, S2, similarly, S3, similarly, S4. Right. So what is this 50%? This 50% is nothing but the variance extracted. It means that the explanatory power of S1 on loyalty. Right? Is it clear?
Yes, sir.
So this is the variance extracted of S1, variance extracted of S2, variance extracted of S3, variance extracted of S4. And when I take the average of it, I get an average variance extracted, which should be greater than 0.5. It means that the overall performance of all these players should be at least more than 50%. Now, why the criteria of 50% has been considered? Why not 10? Why not 70? Why not 60? Why only 50%? Why 50%? So the logic is that the nature's probability is 50%. And if any of your statement is having the explanatory power less than nature's probability, why you will keep that statement into your construct? We want that this statement should have a reasonable explanatory power more than the nature's probability, and therefore we are looking for such statements which can explain more and more and more loyalty. Is it clear? Is it clear?
Yes, sir.
Okay. So the next thing which we have to understand is that this is we are talking about that all the statements are converging towards loyalty. So when there is a convergence, and when you are assessing that convergence, it is known as convergence validity or convergent validity. Right. Now it is quite likely possible that there can be many other constructs in your model. Say for example, now we are having satisfaction. So this is the another team. Say for example, it is a hockey team, and we are having right. So we are having the convergent validity here also. Now there are many variances which can be present. One of the variances is how much is a variance between these two. The variance between these two should not be high, because if this two, the variance is high, there is a problem of high correlation and the multicollinearity. There should not be a high correlation among these statements also. Simple. A hockey player and a football player, they are showing a high correlation, right? So it is not allowed. So when we are looking for that, is it able to discriminate this? Is it able to differentiate between this? Then this is known as discriminant validity. It is known as discriminant validity. So we are getting confused that what is the difference between convergent validity and discriminant validity. Okay, we will make it very simple. Again, let's say you are having two torches. Okay, you are having torch. Those who are the generation, who are the, you can say the, those who have not seen the torches in the olden days, right? Now, if I project this light on the screen, right? If I project this light, okay, so there will be a focal point. There will be a focal point here. It means that all the rays which are emerging from this will converge to this. Similarly, all the states are which are emerging from the construct are converging towards a construct. So when we are testing this, this is convergent validity. Similarly, now we are having another torch, and we are projecting its, we are also projecting this also on the wall. As far as there is no overlapping between the two lights, things are okay. But if the thing starts overlapping, right? So the area where we are confused that this particular ray is coming from this torch or this torch. Similarly, if the statements are highly correlated, we are not able to understand that this statements, is it representing this construct or this construct? When such scenario exists, we say that the discriminant validity is lost. Is it clear? Is it clear? Discriminant validity is lost. Shall I proceed further?
Sir,
Yeah.
so basically the two constructs shouldn't overlap. Is that what it means?
In overlap, there is there is not a concept of overlap. The concept is that it should not have a high correlation among them. The concept is this, right? We should not have a high correlation among the constructs. Okay.
Yes, yes, sir.
Okay. Let us.
So, excuse me,
Uh,
like one is loyalty and one is satisfaction.
uh,
So how they can overlap? So because the items which will form loyalty will be different, and the items which will form satisfaction will be different. So how the two can overlap?
you have asked some statements in which the respondents are not able to understand that this statement belongs to satisfaction or loyalty, or by chance you have asked such a statements that the statement of one construct is showing a high correlation with the statement of another construct, and this normally happens in structural equation modeling. This happens quite number of times. Why it happens, that also I will explain that why it happens, why we don't get discriminant validity. Most of the time we don't get the discriminant validity, most of the time we don't get the reliability. What is the logic? What is the main reason for it? That also we'll have to understand. Okay, shall I proceed further? Any question? Any further questions are there? Please ask. No? Okay. Now, if I talk about AMOS, in AMOS, we will segregate the any SCM. We have to segregate into two parts. One is the measured model, and the second one is the measurement model, or uh, sorry, the second one is a structural model, right? The measured model and the structured model. So you must have all seen the construct, 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 represented by measured variable, one, two, three, one, two, three, one, two, three, one, two, three, and we are connecting them by the covariance. Sorry. Okay. So we are connecting this. So this type of diagram is a measured model. We don't have any regression here. We don't have any uh, you can say path here. There is no path here. The only thing is we are just capturing the covariances between them, between all these models. But when we convert this model into that we are having one construct, then second construct, the third construct, and it's like this, and we are making a diagram like this, where now we are having a straight line, the regression line, right? And we are also capturing the measured variable, right? The measured variable is there, and we are having some variables like this also, and this is also considered, and this is also considered, this is also considered, and this is also sorry, this is also considered, and above this we are considering the covariances between 1, 2, and 3. So this is known as a structural model. We have to always first run the measured model in MS, and then we have to shift to the structural model. Basically, in measured model, we are trying to just see how well our players are representing our team, how well our statements are representing the construct. So this is only we are trying to see, right? And once we are confirmed that everything is fine, then we will change the model and we will shift to structural model. Is it clear? Is it clear with this concept?
Sir.
Yes, sir.
Okay, so uh, structural equation modeling is known as the combination of regression analysis and exploratory factor analysis, right? It is the combination of regression analysis and exploratory factor analysis. Now, what are the characteristics of structural equation modeling? The first characteristics is there is no concept of dv and iv, that this is a dependent variable and this is independent variable. No, here we are using the word endogenous and exogenous, right? We are using the word endo and exo. Clear? Is it clear?
Sir.
Yes, sir. Yes, sir.
Sir, will you please repeat it once again?
There is no concept of dv and iv in structural equation modeling. We are using the word endogenous and exogenous because any variable at same moment of time can be endo also and exo also, and therefore we are using the term endo and exo, right? So with this simple understanding, the SEM, the origin of SEM is way back in 1904. Then the human genetics regression analysis, Galton used it. Then it was used in biology, the path modeling. So it is, you can say, if dependent or independent variable is in scale, we use a structural equation modeling. Scale means Likert scale, right? If it is a Likert scale, 1 to 5, strongly agree, neutral, disagree, then we say that we are going to use SEM. So structural equation modeling consists of, it's a family of many analysis. Can you see this? This is given in the book of Hensler, 2010. Can you see this, all of you?
Yes, sir. Yes, sir.
So the structural equation modeling is a combination of path analysis, confirmatory factor analysis, multiple regression, and the heart of all this is the seed is the correlation. We require a high correlation among the construct, low correlation uh, with the other constructs. So the first one is reliable but not valid. Reliable when not valid means this is consistently giving me the wrong result. It is reliable but not valid. This is having a low validity and low reliability. This is not reliable, not valid. So what we want? We want a scale which is both reliable and valid, right? What is the concept of exogenous? Variables whose causes are unknown and not included in the model, or variables that explain other variables in the model. These are known as exogenous variable. Endogenous variables that serve as DV in model. I will not be using dependent variable. I will be using the term endo. And at the same time, these variables can be IV also. So we say that this is an endogenous variable. Yeah. Now there is something which is known as a path analysis, where we are just talking about the measured variable. Working hours can be measured directly, education can be measured directly, income can be measured directly, and its effect on television viewing. That is a path analysis, right? Then comes the confirmatory effect analysis, which I have already explained to you. The structural regression model is like this, and this is a latent change model. Latent change model means that over the period, what are the changes which have happened in the policy. So I want to see that has the model changed over the time or not. Latent change models. Then we talk about recursive and non-recursive model. Non-recursive model means a path diagram have a feedback loops, while those do not have are called recursive model. A to B, B to C are called recursive models. A to B, B to C, and C to A are called non-recursive models. These models are difficult. There's the last one, are difficult one. Then I have to explain. The intelligence of any person is represented by score in maths, general knowledge score, English score. So your intelligence is a latent variable, and the scores this are measured or indicator variable. And before we proceed, yeah, this one. We proceed. Okay. This is the model on which we are going to work finally. The supervision, the work environment, the behavior of the co-workers affect the job satisfaction. Job satisfaction affects the job search. So the supervision is measured with the help of X1 to X4. Work environment is measured with X5 to X8. Co-workers is measured with X9 to X12. Job satisfaction Y1 to Y4 and job search Y5 to Y8. This is the measurement model which we will be first assessing, and then the structural model. So I'll stop here, and we will again join at 12 o'clock. I had already informed that I am having one meeting, so we will now work on it. My request to all of you is that kindly download the AMOS so that you can work on it. And I'm sending you the, am I not in the position to share anything? I cannot share the file.
Yes, sir. Yes, sir. You can share, sir. You can share it in the chat box, any link if you want. And if you have some files to share, then we can share it in the WhatsApp group which we have, sir.
You include me in the WhatsApp group. I'll send.
Okay, sure, sir. Sure, sir. I'm adding you there.
Okay, so we will start again at what time, ma'am?
12 o'clock, sir.
Yeah, 12 o'clock. Okay, fine.
Okay.
Okay, fine.
So participants, we will rejoin at 12. Thank you.